Okay, quick overview of the lesson from Friday. The biggest thing that I need you to know is about this limit definition of a derivative. This is what it is. This is the equation, the formula that you need. So dy over dx is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. This right here is slope. I'm going to say this like 8 times, but derivatives are slope. Seriously, derivatives are slope. Okay. If you look at the Desmos graph that I linked from Wednesday's lesson, you'll see this thing pop up. But basically all it means is that if you evaluate a function a little bit bigger than the function, and you take the difference between that function and a little bit bigger than that function and divide by that difference, you're going to find the slope at that point. That's what we're looking for. And I want to talk a little bit more about this dy dx thing because it's going to come up a ton. So, about dy dx. The d comes from this. So this is like, we actually started over here and we worked our way back. The d is like, this little triangle means delta. So delta y, delta x. And delta just means change in y, change in x. And that is just rise over run. So this, which is the derivative, it's slope. Derivatives are slope. Cannot stress that enough. So d delta, that's where it all comes from. And important to note, mathematicians love coming up with multiple ways of doing things. So if you have a function, y equals whatever, this is the original function, it has a derivative, and there are 3 different ways you might write that. So these are all the derivatives. You might write y prime is whatever the derivative is. dy over dx is whatever the derivative is. And then f prime of x is whatever the derivative is. All of these mean the exact same thing. You could think about it like 1/2 is the same as 0.5. Sometimes it's more useful to write it like this. Sometimes it's useful to write it like this. These all mean the same thing. Sometimes this is super useful. Sometimes this is super useful. Sometimes I just need it to be this. It's simple. So just be aware of that. Don't let that throw you off. Try sketching the derivatives. We're going to do that. So in class, we did this on Desmos, and you might want to do that, but I'm going to give you a quick little lesson on how to sketch a derivative. So this right here, this is what we're going to call f of x. And in green, I'm going to be drawing f prime of x, or the derivative. Derivative is slope again. So here's what I want you to notice. Here, I've got kind of a positive slope. It's pretty steady, actually, and then it kind of levels off, and then it starts turning negative. So at this point right here, I am switching from a positive slope to a negative slope. If I'm switching from a positive slope to a negative slope, I gotta be 0. So at that point, straight down here, I'm gonna have a derivative equal to 0. Same thing right here, right? Because this is where I switch from positive to negative, and I'm actually gonna extend those lines a little bit so that I can kind of see general idea. Up until this point, I've got a positive slope the entire time. Now, this is going to feel counterintuitive, but I'm going to start with a super positive slope. So I'm going to pick a super positive number. And I'm being pretty kind of sort of with this, but that's okay. And then notice as I move on, here's getting less positive and less positive and less positive. So I'm going to get less positive and less positive and less positive. Okay. In between these 2 dotted lines, I have a negative slope. And first it's not so negative, so not so negative, and then it gets a little bit more negative, and then it starts getting less negative because eventually it gets back up to 0. And then after this, we've got a positive slope, and it's not super positive, and then it gets really positive. So it's going to be not super positive, and then it's getting really positive. Now we can just kind of connect all these dots and get an idea of what our derivative looks like. Now, is this perfect? Of course not. But it is a good kind of sorta. And pay attention again to like the spaces split by these vertical lines, because that's where my original function had a slope of 0. So positive slope, negative slope, positive slope. It's counterintuitive, but if you practice a lot, it will start making more sense.